Hi, my name's Les West. Today I want to talk to you about solving word problems. And the type of word problem that I want to talk about is simultaneous equations in which we use substitution to resolve the equation. So what is a word problem? Well, basically it's usually a single paragraph that tells you a little story. So let's look at an example. Here's a little story. Mr. West and Mrs. East are both keen gardeners and like to grow tomatoes. Mr. West planted later than Mrs. East, and at present he has harvested 40 ripe tomatoes. His plants are producing at a rate of 14 new ripe tomatoes per week. Mrs. East has already harvested 88 ripe tomatoes, but her plants are producing only 12 ripe tomatoes per week. At some point, the two gardeners will have grown and harvested an equal number of ripe tomatoes. So there's the little story. Now what's the problem? Well, the problem you have to solve is going to be expressed in a single sentence question at the end of the paragraph. And that's going to look something like this. How many weeks will it take before they reach that point? That's the point at which they've harvested an equal number of ripe tomatoes. And how many ripe tomatoes will each of them have harvested? Now you'll notice that this question contains two unknowns. And those unknowns are how many weeks and how many ripe tomatoes. So let's express those unknowns algebraically. Let x equal the number of weeks and y the number of tomatoes. Now I've used x and y because they're conventional, but in fact in algebra of course you could use any letters you like. You could use A and B, or you could use T for tomatoes and W for weeks if you wanted to. Okay, so using that notation, let's look at the paragraph and see if we can make some equations from the information we have. The paragraph tells us that Mr. West's plants produce at a rate of 14 new ripe tomatoes every week. He already has harvested 40 ripe tomatoes. So the total number of tomatoes he's going to have at the end of the number of weeks, the number of tomatoes y will equal 14 times the number of weeks plus 40. So there's our first equation, y equals 14x plus 40. And following the same pattern and looking at Mrs. East's tomato plants, y, the number of tomatoes she will finally have, will equal 12x, that's the 12 ripe tomatoes per week she produces, times the number of weeks, plus 88. So now we have simultaneous equations. Y equals 14x plus 40, and y equals 12x plus 88. Now each of these equations gives me a value for y. Y in the first equation equals 14x plus 40. So I'm going to substitute that value for y in the second equation. And the result is 14x plus 40 equals 12x plus 88. In this equation, I want to bring all the x values over to the left-hand side. So I'm going to do that by subtracting 12x from each side of the equation. And the result of that will be 14x minus 12x is 2x, plus 40 equals, the 12x cancels out because I'm subtracting it, so 2x plus 40 equals 88. And to simplify the equation even further, we'll subtract 40 from each side. So that will leave us with 2x equals 48. And of course, if we divide each side by 2, we're left with x equals 24. So now we have solved for the first of our unknowns. X, the number of weeks, is equal to 24. To solve for the second unknown, y, the number of tomatoes, we'll substitute x equals 24 in the first equation. So that gives us y equals 14 times 24 plus 40. Now you can multiply this out either manually or by using your calculator, and you'll get y equals 336, that's 14 times 24, plus 40. So y equals 376. So now we've resolved our problem. We have values for each of the unknowns. X equals 24 and y equals 376. However, we must check this by substituting for x in the second equation. So let's do that. The second equation tells us that y equals 12x plus 88. So y equals 12 times 24, which is x, plus 88. 12 times 24 is 288. 288 plus 88 equals 376, which is the same value we previously obtained for y. So our values are correct. Now, to finish the problem off and to make your teacher happy with your work, you're going to have to write those values which you've calculated into one final sentence. So that sentence will look like this. After 24 weeks, Mr. West and Mrs. East will each have harvested 376 ripe tomatoes. So our problem has been solved satisfactorily and our teacher will give us full marks. Right, well, hopefully that wasn't too difficult to understand. So now we'll just go through one more problem. So here's our second little story. Emma is in training for a long-distance foot race. Her course is divided into lanes, and the inner lanes are shorter than the outer lanes. She would like to run the exact length of the upcoming race to check her times. So her coach gets some measurements made and tells her that one lane is exactly 440 meters per lap. Another lane is exactly 450 meters per lap. If Emma stays in the 440 meter lane for her training run, she will need to complete a set number of laps plus 160 meters extra to complete the distance. If she uses the 450 meter lane, she will need to run the same number of laps plus an extra 50 meters. So the question in this little story is, how many laps does Emma need to run and how long is the race? So our two unknowns are how many laps and how long is the race. So our algebraic expression will be, let x equal the number of laps and y equal the race length in meters. And from the little story we can derive our simultaneous equations. For the first training session, the length of the race that Emma will have to run will be 440 times x, that's the length of the track, times the number of laps, plus 160. And when Emma undertakes the second session, she will run 450x, y equals 450x, plus 50 meters. So y equals 440x plus 160, and y equals 450x plus 50, our simultaneous equations. So now, as we did in our first example when we were talking about tomatoes, we're going to substitute for y in the first of our simultaneous equations. So for y in the first equation, we will substitute 450x plus 50 from the second equation, and that leaves us with 450x plus 50 equals 440x plus 160. And to simplify that equation, and to bring all the x values over to one side, we'll subtract 440x from each side. So 450x minus 440x leaves us with 10x plus 50 on the left-hand side, and on the right-hand side, subtracting the 440x leaves us with 160. So our equation is now 10x plus 50 equals 160. And to simplify this equation even more, we'll subtract 50 from each side. So we subtract 50 from the first side, which leaves us with 10x, and 50 from 160 on the other side leaves us with 110. So 10x equals 110. And of course, to arrive at the value of x, we're going to divide each side of that by 10. 10x divided by 10 is x, and 110 divided by 10 is 11. So the value of our first unknown, x, the number of laps, is 11. And to find the value of the second unknown, the length of the race, y, we'll substitute 11 for x in the first of our equations. Y equals 440x plus 160. So y equals 440 times 11 plus 160. 440 times 11 is 4,840. And 4,840 plus 160 gives us y equals 5,000. So that's the value of our second unknown. Y equals the length of the race, 5,000 meters. And again, as we did in the first example, we're going to check our answers by substituting in the second equation. So in the second equation, we're substituting for x. Y equals 450 times x, y equals 450 times 11 plus 50. 450 times 11 is 4,950. 4,950 plus 50 equals 5,000. So we have correctly established the value of y as 5,000 meters. So remember, as we did in the first example, we now have to write our answer in a final sentence. And of course, that final sentence will read, Emma needs to run 11 laps. The race is 5,000 meters long. Full marks from our teacher again. Well, thanks for watching. I hope this video has been some use for you. I'll see you next time.